Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the 9th part. In this part, we're supposed to determine the standard equation of a hyperbola where given the coordinates of the two foci and the eccentricity of the hyperbola. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola with center at 0, 0. Before we jump into this example right here, let's have a review on the parts, the two cases, and the equation of a hyperbola with center at 0, 0. Please notice that this hyperbola is called a horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus. And there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, A, B, and C, is C squared equals A squared plus B squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is C over A. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now please notice that our vertex is on the vertical axis. That's the reason why our a is under the y. Remember, y means up or down. And that's the reason why the a squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, so we go over the problem here. So we are given the coordinates of the two foci. We have 0 square root of 61 and 0 negative square root of 61. So we're going to change this square root of 61 to its decimal version using the calculator. This would come out 7.81. And so in the other one right here, that's negative 7.81 as well. So we go ahead and plot this two foci right here. So 0 and 7.81. So this is 5, 6, 7.81 should be somewhere up here. So this is our first focus. Well, the other focus is 0, negative 7.81. So negative 5, negative 6, negative 7.81 should be somewhere around here. That's the second focus. Now we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, and the midpoint between the two foci. So in this problem right here, the midpoint between these two foci, you can use the midpoint formula, but we can count it all the way to the middle between these two, and our center is at 0, 0. So we label that as the center. Now looking at this, since these two foci are vertical relative to each other, we can go ahead and say that this is an example of a vertical hyperbola with center at 0, 0. So I'm going to go ahead and write that information up here. Now, since this is a vertical hyperbola, the general equation for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. So we don't have a value for a. We don't have a value for b. However, this distance from the center to the focus is represented as letter c, and that is equal to square root of 61, or that is 7.81 from the center. So that we go ahead and get the values for a and b from this. Now, we remember that the equation that relates a, b, and c is c squared equals a squared plus b squared. Now, looking at this, we are actually going to determine the a and b. We're given the c. However, we don't have a value for both a and b, but we're given the eccentricity. Now, we remember that eccentricity has a formula of E equals C over A. Since our eccentricity is square root of 61, so I'm going to write square root of 61 over 6 equals C over A. So looking at this, we can go ahead and say that our A is 6 and our C was actually square root of 61. That's what we got from there. So that we go ahead and say that again, our A is 6, and so we plug that 6 in here, and the c, which is square root of 61, so that is square root of 61 squared equals our a is 6 squared plus b squared. And so we can solve for b from there, so that the square root of 61 is 61 equals 6 squared is 36 plus b squared, so that we can solve for b from here. So we minus 36 and minus 36. So this comes out, our b squared is 61 minus 36 is 25. This tells us that our b is plus minus 5. So we already have completed it. We have a value for b, which is 5. This tells us that our equation would come out, that would be y squared over the a is 6 squared minus x squared over the b is 5, and we square it, equals 1. So the equation is y squared over 36 minus x squared over 25 equals 1. So this is the equation for this problem that we have up there. So this tells us that our b is 5 and our a is 6. A is the distance from the center to the vertex. So we go 6 up and 6 down because the a is 6. So this is where our first vertex is going to sit, and this is where the other vertex across is going to sit. And so we can go ahead and say that our co-vertex is located 5 to the left and 5 to the right. So this is our co-vertex and this is the other co-vertex. So I go ahead and write the coordinates of the two vertices and the coordinates of the two co-vertices down here. Okay, so we can go ahead and determine the length of transverse axis, that is the distance from the vertex to the other vertex, and the length of the conjugate axis, that is the distance from the co-vertex to the other co-vertex. I'm going to show the work up here. Okay, so the length of the transverse axis is 12, while the length of the conjugate axis is 10. So we can go ahead and sketch the central rectangle for this hyperbola. Okay, we remember that the central rectangle would pass through the two vertices and the two co-vertices. And we can go ahead and sketch the two asymptotes of this hyperbola. The asymptotes would pass through the opposite corners of the rectangle, passing through the center. Okay, now the equation for this asymptote would be, we're going to start with the one with a negative slope. So this would be y equals, again, we go up and over to the corner of the rectangle. So 1, 2, 3, 4, 5, 6. Then we went to the left. 1, 2, 3, 4, 5. So that is 6 over negative 5x. Well, the equation for the other asymptote would be y equals, so we go up 6. And then we go to the right 5, and that's a positive. So that is y equals 6 over 5. So that from here, we can go ahead and sketch the hyperbola. So this is the equation for this problem that we have right here. And this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're given the coordinates of the two foci and the eccentricity. So I'm going to go ahead and change this coordinate here in decimal form using the calculator. So I plotted the two foci here. I labeled it. Now we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. So the midpoint between these two foci is the point of origin, or at 0, 0. So we go ahead and write this as the center. Now since these two foci are horizontal relative to each other, so therefore we can go ahead and say that this is an example of a horizontal hyperbola with center at 0, 0. So I'm going to go ahead and write that information up here. Since this is an example of a horizontal hyperbola, the general equation for horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. So we need to determine the values for A and B so that we can complete this equation that we have down here. Since we don't have an A, we don't have a B, however, we're given the eccentricity. Now we remember that eccentricity is equal to C over A. Since our eccentricity is square root of 41, then our that's over 5, and that is equal to C over A. This tells us that our A is actually equal to 5, while our C is equal to square root of 41. So which makes sense because our C is actually square root of 41, or which is 6.4 distance from the center. So again, this tells us that our C was equal to square root of 41. So then from here, we can say that our A is actually 5. So this tells us that we go 5 steps to the left and 5 steps to the right to get the vertex. So this is our first vertex, and the other vertex would also be across. Since we already have a A and we're supposed to determine the B as well, we don't know what it is, so we can plug the A for now into this equation. So the equation would come out x squared over 5 squared minus y squared over blank equals 1. So I left this blank because we don't know what the B is. So that from here, we can go ahead and write the coordinates of this two vertices. So this one right here. So I'm going to go ahead and write that down here. Okay, again, we're missing the B squared, but we remember that the equation that relates A, B, and C is C squared equals A squared plus B squared. So I'm going to go ahead and write that up here. Since we already have a C, which is square root of 41, we also have an A, which is 5. We can solve B from there, and that's what we're going to put it in here. So I'm going to go ahead and show the work down here to solve for B. Okay, so we have solved the value of B, which is 4, so that we can go ahead and plug this B into this equation right here so we can determine the standard equation of this hyperbola. So our equation would come out. So this is the equation of this problem that we have up there. Now, since we have a B value of 4, remember that the B is the distance from the center to the co-vertex. That means I go up 4 and down 4 to determine the co-vertices. I'm going to go ahead and write the coordinates of these two co-vertices down here as well. Okay, so we can go ahead and determine the length of the transverse axis, which is the distance from the vertex to the other vertex, and the length of the conjugate axis, which is the distance from the co-vertex to the other co-vertex. I'm going to go ahead and show that work up here. Okay, so the length of the transverse axis is 10, while the length of the conjugate axis is 8. So then we go ahead and sketch the central hyperbola and the two asymptotes for this hyperbola. Okay, so we've drawn the central rectangle of the hyperbola. Again, the central rectangle should cover the two co-vertices and the two vertices. And then we've drawn also the asymptote that is from the corner to the other corner of the rectangle passing through the center. And these are the equations for the two asymptotes. So that from here, we can go ahead and sketch the hyperbola. Okay, so this is the equation of this problem that we have right here, and this is the graph of this equation. Did you get the same answers as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!